Hello, in this video I will show you a prototype I've been developing to do capability-based generative UI using WebAssembly components and the WebAssembly component model. And the result, which we're going to replicate, you can see here, you have like a UI for a chat agent. And the idea is that you can dynamically load capability-based and secure components implemented in any programming language that can target WebAssembly components. In this case of this example, I'm going to be using Rust and Moonbeat toolchains to create components. And the idea is that it improves over the current state of generative UI, where either you have a predefined set of available components and it's more of a protocol where you just send JSON and the runtime renders the JSON as components, which is pretty limiting in many ways. The other one is more of iframe as a sandbox, where your components are just web applications inside an iframe, and you like embed them as you would in your page, and you communicate with them using post message, which is not like the idea of a component. That's not actually like a component. It's just a frame set in disguise. So now I'm going to load a new page because like the components here are already loaded. So I'm going to start again, and I'm going to show you the network tab because the application itself, let's remove this. The application itself is implemented in the framework that the components use. So you can see that the biggest file here is the WebAssembly. And it's big because it includes like the application, the framework, but also like a Tailwind compiler implemented in Moonbeat, an HTML sanitizer, a CSS parser, and validator, and to have more security that I will cover later. The JavaScript files are small and are just the glue, providing the glue between the WebAssembly application and the browser runtime. So let's start by asking the component provide. So let's see what's available at the beginning. I provide basically layout components and just one text area just to make it easy to play with it without having to load anything. So it tells me that there's a universal component. That this is a component that when you place it in a place, then you can select others and it becomes those. You have a stack, a grid, tabs, tab page, text, and text area. So I can say create a 2x2 grid empty. This is also another idea here. It's like the agent, let's close this. The agent can create UIs, but UIs are interactive. It can either like pre-populate them or it can give them to you. So I can put here a text area, and now I have like this thing here. I can't put more because I don't have many components, but this can be fixed by going to my list of bundles, and let's say I want, let's start with temperature converter, which is implemented in Rust, as you can see there. I just dropped this tar.gc. It's tar.gc because the browser can natively decompress it, and inside of it, it's core WebAssembly modules and a manifest. This is the JavaScript that it loads is like a bootstrapping code. It's the last thing that I will have to remove to actually make it secure. It's there because browsers right now don't support WebAssembly components. So I compile the components into a WebAssembly component, and then I use a tool called Jcode to compile it down to core WebAssembly modules. And it requires like a small bootstrapping JavaScript that is the last unsecure part of it. So now I just dropped it, and I can say show me as I said, and I think I dropped it, right? No, I think I didn't. yeah, I didn't. So it's trying to do whatever. So let's. So it tried to do it with whatever it had, which is what you would get with ChatGPT or something like that. It's rendered only one. I don't know why it thinks that. Oh, body heat. Okay. So these are interacting components, of course. So I can like body heat, freezing, boiling. I can change one and the others update. So it can use it to show information to me, and it's using the grid to lay out the, I can say now as tabs. And while it does that, we can go and load to do MVC, and let's load also Kanban. And so now I have my tabbed interface with the same information as before, and I can say create a 2-column grid. So create a 2-column grid with a common board and a to-do list for birthday party, and you can see like it created the built-in grid with the 2 components I just loaded and pre-populate them with columns and tasks, and these are like, of course, like interactive components. And let's do 2 more. I guess you get the idea. I have like a base64 converter, a counter, a dice, a JSON editor, JSON formatter, JSON scheme editor and validator, base number base converter. We can do progress bars. But the one I wanted to show you is tic-tac-toe. I can say like show. It's also like when you drop a new component and you want to see what you can do, you can ask it to like show you. So it can do like progress, like steps and timelines. And now I can say so I mean the tic-tac-toe component, it can be like just to play, but it can also be like to display and also to create like some like interactive guide, because the components can like bubble events to inform the runtime that something happened inside the component. So if I click here, it will be informed that I made a movement, and it's showing me the same thing for some reason. I didn't provide an instruction on what it should do when I do a movement. But as you can see, you can use it to display, you can use it to interact, you can use it just to play with a tic-tac-toe match. And as I mentioned before, the reason why the bundle of the root application is kind of big is because it contains the application, it contains the framework, all the framework in the runtime to compile HTML views, to sanitize HTML of the views in the components, to parse and validate CSS. So the injected CSS is scoped and it doesn't have syntax errors, so it doesn't break any other CSS. It also has like a Tailwind compiler ported to Tailwind to Moonbit, so it can compile to Wasm, so it can run in the browser. And it has inside a port of DaisyUI components to Tailwind v4, so it can run in the browser. This means that the components all look and behave the same because they don't ship precompiled CSS. They use Tailwind and DaisyUI classes, but they don't compile ahead of time the classes to CSS. And that is done dynamically when the component loads in the browser. So all the components look the same and they react to themes the same way. And also I can validate that only scoped CSS that is valid, and sanitized HTML for the views, and a shared CSS framework like Tailwind, and a shared set of components using DaisyUI. So they all look and behave the same. And I have to ship all of that into the browser so that I do it dynamically. But with that, we get security by using WebAssembly components and the capability model. So I only provide access to a clock, a source of randomness, and a way to talk back via events. And I validate the CSS, I compile just in time the Tailwind and DaisyUI, I sanitize the views of the HTML. And there's no global CSS, so they are secure, all running in the same DOM document, and I don't have to do iframes, and also I don't have to do like a limited set of components register ahead of time talking JSON like a protocol. It's just components. And so yeah, this is capability-based generative UI using WebAssembly components. And if you have any questions, just let me know. Bye.